A toy for cats consists of a plastic mouse of mass m attached to a spring. When the mouse is on a low friction horizontal surface with the spring attached to a rigid support, as shown here, it performs simple harmonic motion when given a small displacement x from its equilibrium position and released. You can see on the diagram the mouse would be moving forwards and backwards, that way with the spring stretched and compressed. For part A, we need to show that the acceleration of the mouse A is given by this equation, where K is the stiffness of the spring. Since we are considering a spring with stiffness K, let's firstly put down the relevant equation, which is Hooke's law, and that says that the force that the spring puts on the object attached to here, which is the mouse, is equal to minus K times X, where K is the stiffness of the spring, which is this K there, and X is the extension of the spring, which in this case would be the displacement from the equilibrium position. Because at this point the spring is not stretched, it's at the equilibrium position, but any movement away from there would be stretch in the spring, which will determine the force that the spring puts on the mouse. Then we can combine this equation with Newton's second law, since we are interested in finding the acceleration. So we can start by F equals ma, and here m is the mass of the object we are interested in, a is its acceleration, and F is the resultant force on it. Since the only force here is the force from the spring, it's on a horizontal surface, we are interested in the horizontal movement, there is no other force, there is also no friction, because we are told it's low friction surface and horizontal. Then we can put kx in minus kx in there, so that goes as our resultant force, and we say it's ma. Then we can make a the subject, which will give you dividing by m minus k over m x.